Good day, guys. So today we shall be looking at differentiation of a function by chain rule. Okay. What does that mean? So let's say if we have y equals to u, and let's say then we have u equals to x. So this means that if y is a function of u and u is a function of x, that means y is a function of x. You don't get it? Okay. So let me just explain again. Let's say from the board here, if y is a function of u and u is a function of x, it means that this y is a function of x. And that's where this one comes in. Differentiation of a function of a function. Okay. So whenever we have functions wherein we have brackets like this and we have powers, like we are dealing with powers, okay? If you want to differentiate short functions, we always use chain rule. That's one way. And chain rule says that dy by dx is equals to dy by du multiplied by du by dx. So this and this again just cancels. So we are left with dy by dx. But this is the formula actually. Okay. So it's dy by dx equals to dy by du times du by dx. So that's chain rule. So what happens here? Whatever you see inside the brackets here from these examples, you are going to let that whole function, those variables and letters to represent to be u. Then you are going to differentiate u with respect, you are going to differentiate y rather with respect to that u. Okay? And the u, of course, you've left, you are going to differentiate that with respect to x, or let's say y, depending on the variable inside the bracket. Okay? So now that's one way. And the other way for us to do that, guys, I know maybe I'm shouting, and that because I'm living in an environment that is actually noisy. So I'm trying in as much as I'm using this. I'm trying as well just to keep up that noise. Okay. So, but I'm quite sure you are all fine. So the basic rule about differentiation is that when we have the function, let's say x raised to the power n, and let's say this is the variable we are differentiating. Let's say y equals to x raised to the power n, and n is the power. If we want to differentiate this, it's just you multiplying n by the coefficient of this and subtract 1 from n. So you multiply the power by the coefficient of the variable you are differentiating and subtract 1 from that power. Okay? So it means this is going to be nx raised to n minus 1. So that's the basic thing. So now you can apply a direct method for us to differentiate short problems like this, by just, and that's it. And that is, you multiply 5 by the coefficient here, okay, and subtract 1 from the power. Then the only thing you have to add there is that you are now going to differentiate again what is inside the bracket. What do I mean? So let's say if you have something like this, let's say this is inside the bracket. Now if you want to differentiate this is 1, multiply now by the differential d by the x of x by what's inside the bracket. So the whole of this. Okay, let's get into the problems and see how we solve these problems. Maybe you will understand better if in case you don't understand this. Okay, so just give me small time. Okay, so we are going to keep this one here. So we are going to keep this formula here. So we will have to look at it. So let's look at the example 1 there. Example 1 says y equals to 3x plus 4 all raised to the power 5. Now we want to differentiate x with respect to u. Okay? I mean with respect to Why here? So we are differentiating this one, okay, with respect to this. So now we want to differentiate y with respect to x. So this means dy by dx equals to, now the direct method, you are multiplying 5 by the coefficient here. That gives you 5 into 3x plus 4 all raised to 5 minus 1. Okay? Then you are now going to differentiate what's inside the bracket. So the differential d by dx of what? 3x plus 4. Now I have not differentiated this one. I just put it exactly how you should differentiate. So now this is going to be 5 into 3x plus 4 all raised to the power 4 multiplied by, if you differentiate this one, what's inside the bracket, you have what? 3. Okay, so now what you have to do, you multiply 5 times this gives you 15 into 3x plus 4 all raised to the power 4, which is your answer. Okay, so it's actually very simple. It's actually very simple. Now let's use the formula now. Let's say we want to use the formula. Okay, so the formula of course says dy by dx equals to dy by du multiplied by du by dx. So as I told you previously, you let what is inside the bracket to be u. So let's say let u equals to 3x plus 4. Now you are differentiating u with respect to x. So du by dx equals to, when you differentiate a constant is 0, and if I'm differentiating this one, remember I'm taking 1 here, multiplying it by this and subtracting 1. So 1 minus 1 gives you 0. Okay, so when you differentiate 3x, you have 3. You want me to do that? So let's say this is 3x and you are differentiating this. The power of this is already 1. You multiply 1 times, this gives you 3x again, and you have 1 minus 1. When you subtract this one, you are going to have 3x raised to the power 0. Any number raised to the power 0 is 1. 3 times 1 gives you 3. And if I differentiate a constant, is 0. And there is, of course, I have given the basics on how to differentiate all of this, how to differentiate a constant. Okay? So in case you don't get this one, please check my YouTube channel. You will be able to see. And unless I forget, before I forget rather, my YouTube the channel is Madi Jibuma channel, okay? So don't forget to subscribe, share, and like. Okay, so now we've differentiated this. So remember, it says y equals to the of this, but we've let this one to be u. So now y is now u raised to the power 5. So now we are now differentiating y with respect to u. So dy by du equals to, this is 5u raised to the power 4. All we have to do now is just for us to write the formula. And remember, the formula says dy by dx equals to dy by du. Dy by du is 5u raised to the power 4 multiply by du by dx. Du by dx is 3. Okay, so the answer dy by dx equals to, if you multiply this, gives you 15u raised to the power 4. But remember, the variables we are dealing with is y and x. So we have to bring in x again. But remember, we let u to be something. So we now replace u with whatever we let before this time. So we have dy by dx equals to 15 into, what is your u? Your u is 3x plus 4 all raised to the power 4. So that's your answer when you use the formula. So whether you use this formula or use the direct method wherein you differentiate the bracket and then differentiate what's inside, you differentiate with respect to the power, and the next thing you differentiate what's inside the bracket, you still have the same answers. Okay, so let's look at number 2. Okay guys, so let's look at example 2. Example 2 says y equals to 2x raised to the power 2 minus 5x all raised to the power 2. So if you're using the formula, we let u equals to, what is inside the bracket, 2x squared minus 5x. So now we are differentiating u with respect to x. Du by dx equals to, We multiply this, it gives you 4x, and you are subtracting 1, so that's just 4x raised to the power 1, which is 4x minus. We are differentiating this one, we have 5. This is 1 multiplied by this is 5. You subtract 1 minus 1 gives you 0. Any number raised to the power 0 is 1. So 5 times 1 is 5. So this is it. So differentiating this one, you have 4x minus 5. Now remember, this was y equals to the whole of this. But we've left this one to be u. So now we have y equals to u raised to the power 2. We differentiate y with respect to u. Dy by du equals to 2u raised to the power 1. So it's just 2u. Now from the formula, it says dy by du equals to, what is your dy by dx equals to dy by du. Dy by du is 2u multiplied by du by dx. So it's actually very simple. We have 4x minus 5. So we are just to multiply this one. That's it. But remember, what is your u? So this is equals to 2 into, what is my u? My u is 2x squared minus 5x. Everything here multiplied by 4x minus 5. Now, you can leave your answer this way. At least let's just try to further simplify. Okay, so here you just multiply. This gives you 4x squared minus 10x. Okay, by 4x minus 5. Okay, further down, this and this gives you 16x cubed. Okay, this and this gives you minus 20x squared. This and this gives you minus 40x squared. Okay, then in the last one, this and this gives you plus 50x. Okay, so this is going to be 16x cubed. This and this gives you minus 60x squared plus 50x, which of course can leave your answer. What is common here? 2, 4. So 2 is common. If you take 2 here, we are left with, and 2x, we are left with 8x squared, and this gives you minus 30x. Okay, because remember you've taken x, and this one is going to be 25. Okay, so that will be your answer for this particular problem. Now let's say if you don't want to use this one, so remember this is our answer. If you want to use the other method, you can still use the other method. That's the direct method. Okay, so the direct method, again, you are multiplying here. 2 multiplied by everything here gives you 2 into 2x squared minus 5x. Okay, so you differentiated the power. Now multiply by, if you differentiate what's inside the bracket, that gives you 4x, okay, minus 5. So you still have the same thing here as this one. Simple. Okay, so let's look at the next example. Okay guys, let's look at example 3. Example 3 says y equals to 3x raised to the power 4 minus 5 all raised to the power 7. So it's more like the same thing. Okay, here again we let u equals to 3x squared, 3x raised to the power 4 minus 5. Now you differentiate du by dx. Du by dx equals to, so this one gives you 12x cubed. Remember, you multiply and subtract 1. And when you differentiate, the constant is 0. So you forget about it. So remember, this is now y equals to u raised to the power 7. So now you are differentiating dy by du, which is, this gives you 7u raised to the power 6. Okay, now all you have to do, you apply the formula. Your dy by dx equals to, dy by du is 7u raised to the power 6 multiplied by 12x cubed. We change this one to its power to where it is. Okay, so that gives you 7 into, what is your u? Your u is 3 x raised to the power 4 minus 5. Okay, but this u is raised to a power, that's 6 multiplied by 12x cubed. So now you can multiply this one, this and this gives you 84 x cubed into 3x raised to the power 4 minus 5 all raised to the power 6. Okay, so that's it. That becomes your answer if you are differentiating this one. So it's actually very easy. How many steps? If you want to use the direct method, it's the same thing. You multiply this. Direct method, you multiply this, that gives you 7 into 3x raised to the power 4 minus 5 all raised to the power 6. Multiply that, okay, by, now you differentiate what's inside the bracket. That gives you 12x cubed again. So it's just the same thing, okay? So let's look at the last problem, and we are going to solve the 5. So I'm going to change this one to 2 raised to the power 3. Yes, I have a reason for that, so I want to make it more complex. Okay, so let's look at the last problem for this particular video. Okay, so it says y equals to 1 over 1 minus 5x all raised to the power 2 over 3. So when you see this one, we are in the power here. Okay, there are two things here that you must have noticed that are totally different from the other problems we solved. One, this one is more like a division, where in all of these we are not in any form of short. And this again, the power of this is a fraction, where in the ones we solve we are not. Okay, so the first you have to do, you have to change it to this form. How? This is 1 over, and once you are changing it, so not differentiated, we just want to change. So this one is going to be 1 minus 5x all raised to, because you are taking it up, this one changes to minus 2 over 3. So now instead of it being a fraction here, now it's more like a whole number, having the power being negative. Okay, so now we can differentiate using the direct method or using the chain rule. Okay, so first we have to determine, we have to let u equals to 1 minus 5x. Now we are going to differentiate du by dx. And remember, when you differentiate a constant is 0, we differentiate this becomes minus 5. Okay, then we have now y equals to u raised to the power minus 2 over 3. Okay, because you've left the whole of this to be u. Then now we are differentiating dy by du equals to, first you multiply this and subtract 1 from the power. So this gives you minus 2 over 3. Okay, now you have u. Now you are going to have here minus 2 over 3 minus 1. So you just have to divide this by 1 and find the LCM. That gives you minus 2 over 3. This is u. And this one, the LCM, this is 3 minus 2 minus 3. So you are going to have minus 2 over 3 u minus 5 over 3. Okay, so now you apply the formula. According to the formula, it says dy by du equals to dy by dx rather equals to dy by du. So my dy by du is what? Minus 2 over 3 u raised to the power minus 5 over 3. Multiply this, okay, by what is your du by dx? Du by dx is minus 5. So now this will give you, if you multiply this and this, gives you positive. So that's 5 over 3 u raised to the power minus 5 over 3. But what is your u? Your u is 1 minus 5x. So the answer is going to be 5 over 3 into, what is my u? Is 1 minus 5x all raised to the minus 5 over 3. Now you have to take it back to this form. So if you are changing this one, it gives you 5 over 3 into, so this is now 1 upon, okay, 1 minus, so you have, let me get this one properly. So this is 5 over 3 multiplied by 1 upon 1 minus 5x all raised to the power 5 over 3 positive now. Okay, so your final answer is going to be 5 at the numerator, then you are going to have 3 into 1 minus 5x all raised to the power 5 over 3. Okay, as your answer. So this is the final question. Remember, don't forget to subscribe, share, and like the video. Give the video a thumbs up. Okay, and click the notification button so that when I upload a video, you will be the first to be notified. Thank you so much if you've been with me so far. Okay, so please share the content even if you don't subscribe so that others who may be interested in short content will be able to get access to this and be able to visit the channel. Thank you so much.